What's up guys, this is Massey. Welcome to another video. In this video I want to talk about end behaviors of polynomial functions. The degree and the leading coefficient in a polynomial function indicate the end behavior. In the previous videos I talked about finding the degree and leading coefficient of polynomial function. I want to explain how to find out end behaviors of these functions. If we have an odd degree polynomial functions, odd degree polynomial functions are those functions with the degree of 3, 5, 7, and so on, can have opposite end behavior. For example, sometimes the leading coefficient of this polynomial is negative, sometimes the leading coefficient is positive. If the leading coefficient of this polynomial function is negative, then we can say it extends from the second quadrant to the fourth quadrant. It means that as x goes to negative infinity, then y goes to positive infinity, and as x goes to positive infinity, then y goes to negative infinity, which means that it is gonna be something like this, or something like this. So it goes from quadrant 2 to quadrant 4. That's when we have the odd degree polynomial with the leading coefficients of negative numbers. So whenever the leading coefficient is negative and we have odd degree polynomial, it extends from quadrant 2 to quadrant 4. It means that as x goes to negative infinity, y goes to positive infinity, and as x goes to positive infinity, y goes to negative infinity. So that's for odd degree polynomial with negative leading coefficient. Now let's take a look to the positive leading coefficient and odd degree polynomial. As you have it, the function extends from the third quadrant to the first quadrant. As x goes to negative infinity, y goes to negative infinity, and when x goes to positive infinity, y goes to positive infinity. For example, in this case, it's gonna be here. If we have this, it's gonna go like that. This is the quadrant 1, and here is quadrant 3. As x goes to negative infinity, y goes to negative infinity, and when x goes to positive infinity, y goes to positive infinity as well. Alright, so these are the odd degree polynomial function. Let's take a look to the even degree polynomial function, like 2, like 4, like 6, and so on. If the leading coefficient is negative, then the function extends from the third quadrant to the fourth quadrant. So when x goes to positive or negative infinity, then y goes to negative infinity. For example, for this even degree polynomial, if the leading coefficient is negative, it's gonna be something like that. So there is quadrant 3, here is quadrant 4. As x goes to negative infinity, y goes down, negative infinity, and as x goes to positive infinity, y goes to negative infinity as well. Sometimes it is like that as well. So it needs to have both sides is falling down. So that's the even degree polynomial function with negative leading coefficient. Now let's take a look to even degree polynomial function with positive leading coefficient. If the leading coefficient is positive, then the function extends from the second quadrant to the first quadrant. So as x goes to negative or positive infinity, then y goes to positive infinity, which means that it is going to be like that, like this, or like this. So basically from both sides it goes up. As x goes to negative infinity, y goes to positive infinity, and as x goes to positive infinity, y goes to positive infinity as well. So these are the end behavior of this polynomial function. Let's have some examples here. So we need to state the end behaviors of the polynomial functions here. So the first example I have is 3x to the power of 4 plus 5x to the power of 3 minus 6x squared plus 2. So as you see here, the order or degree of the polynomial is degree is 4, and the leading coefficient is 3. So it is even number, and we have a positive leading coefficient. So it means that as x goes to negative or positive infinity, then y goes to positive infinity. So it extends from quadrant 2 to quadrant 1. So that's basically, it's going to be the end behavior of this polynomial. Next one is f of x 2x to the power of 5 minus 7x to the power of 2 plus 8x plus 1. In this example, the degree is 5, which is odd number, and the leading coefficient is 2, positive. So odd number, and it is positive, so it is gonna extend from quadrant 3 to quadrant 1. So as x approaches negative infinity, then y approaches negative infinity, and as x approaches positive infinity, then y approaches positive infinity. So it extends from quadrant 3 to quadrant 1. Next one is f of x negative 3x to the power of 3 plus 5x minus 1. This example, the degree is 3, odd, and the leading coefficient is negative 3. So that's negative. So as x approaches negative infinity, then y approaches positive infinity, and as x approaches positive infinity, then y approaches negative infinity. So it's going to be, it extends from quadrant 2 to quadrant 4. Now let's take a look to this example. If you have negative 3 x minus 1 to the power of 2 times x plus 1 to the power of 2. This case we have the degree is 4, is even number, and the leading coefficient is negative 3, so it's negative. So as x goes to negative infinity, then y goes to negative infinity, and as x goes to positive infinity, then again y goes to negative infinity. So it extends from quadrant 3 to quadrant 4. So these are the end behavior and the examples. I hope you enjoyed this video. Please leave me a comment if you have any question, and if you found it useful, please subscribe this channel. You can find out lots of videos in this channel regarding chemistry, math, and physics. Thank you for watching and have a great day.